Another type of fitting used to make branch connections is the coupling. Used primarily for connecting small bore screwed or socket weld pipe to large bore pipe headers, the coupling is also used where instrument connections are needed. There are two common methods used to make branch connections with couplings. In the first method, the coupling rests on the external surface of the pipe header and is welded from the outside. In the second method, a hole is bored into the pipe header large enough to accept the outside diameter of the coupling. The coupling is inserted into the hole and is then welded. The following figure shows the drawing symbols for a coupling using the first branch connection method. Here, the coupling is welded onto the pipe header. This next figure depicts the second connection method. Here, the coupling is inserted into the pipe header and then welded. Keep in mind, because of it being a branch connection, the nominal pipe size and the exact position of a coupling must be provided on a drawing, typically the isometric fabrication drawing. Now, isometrics are beyond the scope of this course, but if you feel like you want to know more about these technical drawings, then we strongly encourage you to check out our bestseller course on isometrics. Finally, this last figure shows the single line and double line representation drawings of couplings. In this video, we're going to talk about pipe reducers. Let's have a closer look. Actually, when you want to reduce the diameter of a straight run of pipe, a reducing fitting must be used. The reducer is available in two styles: concentric, as seen here, so having a common center line, or eccentric, having offset center lines. The differing characteristics of these two reducers are quite noticeable. The concentric reducer maintains the same center line through both the large and small ends of the fitting. Conversely, the eccentric reducer has offset center lines that will create a flat surface on either the top or the bottom of the fitting, depending on how the fitting is rolled prior to welding. Now, what I want you to keep in mind here is that there are specific situations where the eccentric reducer must be installed with its flat side on the top or the flat side on the bottom of the fitting. To better illustrate this concept, take a look at the following example. The pipe that you can see here includes one eccentric reducer, highlighted here in green, and one concentric reducer, highlighted in blue. The pipe is routed through a pipe rack. It naturally rests on the steel beams and is supported throughout its length. But at a certain point following the concentric reducer, the pipe changes its pipe size while in the pipe rack. It does not rest on all steel supports anymore. The small end doesn't have a diameter large enough to touch the steel supports. Therefore, an eccentric reducer must be used in this pipe rack, as highlighted here, to maintain a constant bottom of pipe and to ensure the pipe will rest on all the steel supports for safety and mechanical integrity of the piping system. Okay, now when representing the reducer on a drawing, it is necessary to include a note that identifies the reducer's size and type, as seen here, as well as its orientation. In this example, the reducer is to be installed with its flat side on the bottom. Therefore, the abbreviation FOB in the note instructs the fabricator how to install the reducer. FOB for flat on bottom, as opposed to FOT for flat on top. Eccentric reducers are also used on pump suction nozzles, as in this example, to keep entrained air from entering the pump. By keeping a flat on-top surface, vapor pockets can be eliminated. The figure that you can see here depicts the installation of an eccentric reducer installed on a pump suction nozzle with the flat surface installed on the top. Therefore, FOT. Now, an important aspect that needs your attention. It is important not to forget to include the dimensional difference between the two center lines of an eccentric reducer when calculating the elevations of a pipe in a pipe rack. The formula for calculating this difference is highlighted here. A quicker but less accurate method is to take 1/2 the difference between the two outside diameters. Okay, let's now shift our attention to drawing symbols for the concentric and eccentric reducer. The orthographic views for the concentric and eccentric reducers are shown in this figure. No matter what the size of the reducer is, it is always drawn as a double line symbol. Notice the callouts that must be included with the eccentric reducer. The large end is always listed first, no matter what the direction of flow is, and the flat side must be indicated. Recall whether FOB for flat on bottom or FOT for flat on top. Okay, now to finish off this video on reducers, the length of these fittings can be found on the following dimensioning chart. Here, the H dimension will provide the end-to-end length for either the concentric or eccentric reducer as a function of the pipe nominal size. This chart is also available in the downloadable resource section.